Okay, welcome ladies and gentlemen to 8.2. This is what we call the Law of Cosines. This is to go along with our Law of Sines section from 8.1. This is actually it's a pretty straightforward law. This one doesn't have any of that ambiguity like the SSA version. But let's just go ahead and get right into it. Now, there are ways to derive this equation, but I'm going to kind of leave that out of the video today. I'm just going to kind of give you the law of sines itself. So today, or not today, this particular lesson deals with the SSS or the SAS parts of a triangle. So if you were given a triangle that looks like this, and you were given 4, 6, and let's say 5, like this would be the SSS version. And if you're given SSS, that means you're going to use the law of sines because the law of not the law of sines. Use the law of cosines because the law of sines wouldn't work because you're not given any of the angles. Or if you're given a triangle that looks like this with 2 sides and the included angle. If you have 2 sides in the included angle, notice again the law of sines does not work. I don't have angles that are opposite these 2 sides. But the law of cosines does work for those 2 types of triangles. So here's what it's going to look like. I'm going to give you all 3 variations. This just depends on what you've been given. So this first set like this is good for the SAS. This is good for SAS because what you're trying to find is you're trying to find this side length, this third side, which means you were only given 2 to begin with. So if you're given 2 sides and the included angle, you would say, okay, here is a squared equals b squared plus c squared minus 2bc times the cosine of a. Very straightforward. It just looks kind of complex. There is a second form. This is for the SSS version. And this means since you're having SSS, that means you're looking for an angle, which means I need to solve for cosine of a right here. So I would minus b squared and minus c squared and divide by negative 2bc. And I would get this particular version right here. So I would say, if you want to write this a little bit differently, you would say it's cosine of a is equal to b squared plus c squared minus a squared all over 2bc. And that's if you want to write it as fraction form like that rather than the divide sign. And then you have to remember that in order to solve for a right here, you actually have to do cosine inverse of this big thing here. So whatever number you get there, you need to do cosine inverse to find angle A. So you got to remember that this first part here is for SAS. And this second version, which is all the same thing, just dependent on what you're going to look for first, is for the SSS version. This means you're going to solve for an angle first in the other form. And you'll be pleasantly surprised kind of how the law of cosines work here because you only have to do the law of cosines once. And as soon as you do the law of cosines once, you actually have enough information for the law of sines. And then once you do the law of sines, then all you need to do is actually do the angle sum of a triangle. Because you'll notice that you actually, in both of these, the SAS, you need to solve for 2 angles. And the SSS, you need to solve for 2 or 3 angles. So you'll end up subtracting to find the third angle. So it's nice the way this works. You do law of cosines, then you do law of sines, and then you do 180 minus angle 1 and angle 2, whatever angles you have there. So you kind of do this process. You can do law of cosines all 3 times, but it's just a little bit more work than is necessary. All right, so let's take a look at an example. I'm giving you A, B, and angle C. So if you were to draw this triangle out, I don't care where you'd put stuff. I just usually draw it like this. And I have little a is 11, little b is 5, and big C is 20 degrees, which means I have SAS. And with this version, I'm going to solve for a side first. I'm going to solve for the missing side, little c. So I know little c squared is equal to a squared plus b squared minus 2ab times the cosine of big C. And then all I have to do now is plug stuff in. I say, okay, c squared is equal to a squared, which is 121, plus b squared, which is 25, minus 2 times 11 times 5 times the cosine of 20 degrees. Make sure your calculator's in degree mode. And if I take the square root of that number, I get, takes a little second to type it in here, so square root of 121 plus 25 minus 2 times 11 times 5, cosine of 20, and I get 6.53. So now I know little c is 6.53. And now that I have an angle and the side across from that angle, and I have a side and a missing angle, I can use law of sines. And if you're going to do law of sines here, make sure you're looking for the smaller of the two angles. Okay, I know that angle B is smaller than angle A because of the side lengths that are opposite. And the reason I have to do this is because sine won't give you an obtuse angle. So let's make sure we look for the small angle first. So we're going to say, okay, since I'm looking for an angle, let's say it's sine of big B over 5 is equal to the sine of 20 over little c. And I'm going to use the exact answer like I've been doing before. And multiply by 5 and take the sine inverse. So B is equal to the sine inverse of 5 sine of 20 over c, whatever c was. And I'm going to go straight to that. Sine inverse of 5 sine 20 divided by answer. And I get B is 15.18 degrees, approximately. And obviously from there I have two angles in a triangle, so I'm gonna do 180 minus 20 minus my answer, and I get 144.82. So 180 minus 20 minus A and S, and I get 144.82 degrees. And there we go, I've solved the triangle. And this kind of makes sense the way this goes, because across from the 15 has to be my smallest angle. Across from the 20 has to be my middle angle, or my middle side. And across from the 144 better be my bigger side. Okay, let's try another one. I think I have another one here for SSS, I'm assuming. Okay, so I'm given side, side, side. So I always like to just draw triangles, A, B, and C. So little a here is 9, little b is 7, and little c is 5. So now it just depends on what you want to find. Let's in this version, I like to find the largest angle for law of cosines, because cosine will give you an obtuse angle. So let's say the cosine of A. I know A is the largest angle because it's across from the largest side. So cosine of A is equal to what? I gotta rewrite my stuff here. So A squared equals B squared plus C squared minus 2BC cosine of A. All right, so I get b squared plus c squared minus a squared over 2bc. I have to write, I can't seem to remember this one, so I always write out the one that I memorize, and I go from there. Okay, so cosine of a is equal to b squared plus c squared minus a squared all over 2bc. So that tells me that a is equal to the cosine inverse of b squared, so 49, plus c squared, which is 25, minus a squared, which is 81, all over 2 times 7 times 5. And we can go ahead and do that straight. We can say cosine inverse. I'm going to put a parentheses for my numerator, so 49 plus 25 minus 81. And I'm going to divide by parentheses 2 times 7 times 5. Close all my parentheses. And I get A is approximately 95.74 degrees. And now that I know this angle, I can use the law of sines because I now have angle side side, or angle side side. That's what I have here. So let's go ahead and take a look. Let's go sine of b over 7. I don't have to find the smaller angle now because A is my only obtuse angle that's allowed in my triangle, so it doesn't matter which one you do now. So sine of b over 7 equals the sine of a over 9. And I'm going to use a because I'm going to use the exact answer I got before. So I know b is the sine inverse of, if I multiplied by 7 over here, 7 sine of a over 9, which is approximately, let's see here, sine inverse of 7 sine answer. Divided by 9, and I get 50.70. And now I just got to solve for my third side, and that's just 180 minus, I'm going to go up and use 50. I'm going to go use that 95 that I have exact, and I'm going to go to, because I did something wrong. Okay, there we go, and I get 33.56 degrees. And now we've solved the triangle. All right. So here's this first one that I gave you is the SAS version. So this was SAS. And the second one here was SSS. Oops. Forgot I had another word problem on here. All right, so bases on a baseball diamond are 90 feet apart, and the pitcher's rubber is 60.5 feet from home plate. I want you to find the distance from the pitcher's rubber to first base. Now, many people believe that a baseball field is a square, and technically it is. It's a diamond, obviously. But a lot of people actually think the pitcher's mound is in the dead center of the field, and it's not. The pitcher's mound is actually not dead center. It's actually moved forward just a little bit. So pitcher's mound is right there. Now what we're going to be trying to find is the distance from the pitcher's mound to first base, given a little bit of other information. So we're given that the distance from the pitcher's rubber to home plate is 60.5, and the bases are 90 feet apart. And then what you do need to know is, since the pitcher's mound is centered left and right, the home plate sits at a 90-degree angle. So running in from third base, going to first base this way, that's a 90-degree. And this straight up and down green line, even though it doesn't look straight up and down, actually cuts it in half to make this a 45-degree angle. And once you know that, you now have side angle side And you can use the law of cosines to solve for x. And if we did that really quick, I know x squared is equal to 90 squared plus 60.5 squared minus 2 times 90 times 60.5 times the cosine of 45 degrees. And I'm just going to find the square root of that so I can find that x is equal to something. Square root of 8100. Let's just do 90 squared plus 60.5 squared minus 2 times 90. And I get 63.72 feet. Not that hard of a word problem, but people just, they want to believe what they want to believe. This pitcher's mound is not dead center of your baseball field, and you can go look at a real baseball field if you don't believe me. All right, so that's that. There's one little leftover thing here to do, and that's area. And if you are given side angle side, you can find the area by doing half of BC times the sine of A. And I think I gave this to you on the last lesson, but I'm giving it to you again. With side angle side, it's half BC sine of A. So if you're given something like this, and you are given A, B, and C, here's little c, and here's little b, and here's angle A. So if you're given side angle side, it's 1/2 times b times c times the sine of angle A. That'll give you the area of your triangle. And what's really cool is you can actually find the area of a triangle if you're only given side, 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 and that doesn't require any trigonometry. And it's called Heron's formula, named after somebody in ancient times. And what it is I'm going to write this a little bit differently. Oops, let's write it over here. Square root of s times s minus a, s minus b, times s minus c. And a, b, and c are the side lengths of your triangle. And s is what we call kind of a, I think they call it the semi-average. It's taking the sum of the three sides of your triangle and dividing by 2. So if I had side lengths of 6, 5, and 4, and that's all you were given, you would do, to find s, you would say it's 6 plus 5 plus 4 all over 2, which is 7.5. And then you would do 7.5 times 7.5 minus 6 times 7.5 minus 4 and 7.5 minus 5. And that would be the area of your triangle. Just straight up, no trigonometry involved. But it is kind of cool formula, one that you're going to be asked to do here. And that's going to leave with this. I'm going to not do that because I just kind of did the example there. Leave you with your assignment that's on your assignment sheet. Have a good evening, afternoon, and I will see you guys tomorrow.